Hello, this is Jim McKeeth, and welcome to this CodeRage 9 session on FireUI and the MultiDevice Designer. FireUI is a new feature in XC7, and it is the evolution of the FireMonkey Designer. It combines all of the FireMonkey application types into one application. So you no longer have to have a separate application for your Windows and OS X and another application for iOS and Android. They're all combined into one. And it's actually made up of three different technologies. The first technology that kind of is behind the scenes is called behavior services. And this provides runtime and design time platform design information. The second technology is called the MultiDevice Designer. And this is the designer that allows you to have design your UI once and then modify it and tweak it to get the perfect customization for all your platforms. And then the last part of the FireUI technology is the MultiView component. And this is an adaptive layout control that is just absolutely fabulous. So let's go and take a look at each part individually. First part, like I said, is behavior services. Behavior services is based on the idea that every platform is different and has different behaviors. So behavior services mostly runs behind the scenes, and it provides a way for your app and your user interface to adapt and know what the behavior should be like on the platform it's on, based on screen orientation, screen size, OS, etc. One of the ways you're going to see this is there's a new platform default size, platform default position, and platform default behavior on some of the controls. So for example, the T-tab controls tab position defaults now to platform default. And what this does is it puts the tab control, the tabs, on the bottom in iOS, because iOS says you should put your tabs on the bottom, and on the top for all the other platforms. You're also going to see the font size and font family have a platform default behavior, and many controls have a size platform default. And this sets the control size to be the default for the platform. That way you don't have to tweak the size of your buttons, for example, on different platforms. That automatically will adapt the correct size for the platform it's running on. So at runtime, if you want to access behavior services, you can. The main purpose of behavior services is that it can be used at design time to influence the behavior of your controls, but you can access the T behavior services class, which is in the FMX behavior manager unit. So it defines, has two interfaces you can use. One is iBehavior or iDevice behavior, which defines the getDevice class, which will return a device class. GetOS platform, which will tell you if it's OS 10, Windows, iOS, or Android. And getDisplayMetrics. You can also use the iFont behavior interface to find out the default font family and the default font size. So here's an example of using it to get the device behavior, get the OS in this example. So we check to see if it is iOS, and if it is, first we have to check to see if it supports that iDevice behavior interface. And if it does, then we can use that to get the OS platform and check to see if it's iOS, and then have specific behavior for iOS. Here's an example using display metrics. So we get the display metrics from the device behavior and check for the aspect ratio, and then we do different behaviors depending on what the aspect ratio is. This is what the record of display metrics looks like as far as what it contains. It has the physical screen size, the logical screen size, and the difference is the physical screen size is the actual physical number of pixels on the screen, whereas the logical screen size is what the screen size is based on the pixels per inch, or the density of the screen. So for example, the simplest example is the original iPad had 1024 by 768 pixels. Then the new iPad Retina display had 4 times that, so it's twice as wide and twice as long, so 2048 instead of 1024. That was the physical screen size, was 2048 wide, but the logical size was still the same. It was still a logical screen size of 1024. Okay, so that's the difference between logical and physical. We also have the scale, font scale, aspect ratio, and pixels per inch there. So aspect ratio is going to tell you landscape versus portrait, for example. All right, so now let's take a look at the MultiDevice Designer. The idea behind the multi-device designer is you first create a master view, and the master view contains all your controls and lays out like you would normally lay things out. So you're going to use all your alignments and your anchors and your margins and your padding, etc., just like you did before on your master view. But then you can create device-specific views. And so you only create device-specific views on platforms where you want to tweak your layout. Okay, so you can move things around on different layout. So for example, on your iPad, you might lay things out differently than you would on your iPhone. This actually uses stream inheritance to only store the differences between the different views. So if you wanted to have components only visible on certain views and on other views, like I said before, they all exist on your master view, but you can then hide them on specific views. So if you don't want them on your iPhone because you don't have enough screen real estate on the iPhone, you would hide them on the iPhone and then have them visible, the visibility set to true on the iPad. So there's only one form class for all platforms. So your class file where you're writing your code, there's only one instance of that form. You only have one set of code that you're writing there for that. But then there's multiple FMX files. Now the main FMX file contains everything in it. And then the other ones, the ones that are specific to the device, are the stream inheritance, the difference between the main and that one. So it only contains the differences in there. And you can see here the code for how it references the multiple FMX files. So the compiler is only going to include the ones for the current platform. So if you have 5 different Androids and 4 different iOS FMX files, when you compile for Android, it's only going to include the Android ones. When you compile for iOS, it'll include the iOS ones, and it'll always include the main one. So the star.fmx is the main one, whereas the iPhone 4-inch .fmx is the iOS 4-inch specific one. Now it comes with a nice selection of default views that you can use, device views you can use, but if you want to add custom views, like for example, for the new Android Wear watches, you can certainly do that. And the information you need here, all you have to do is create a unit in a package that creates a tDevice add info, or calls tDevice add info in the initialization section, and then in the finalization section removes that device. And so in add device, you're going to define what that device looks like. Then you also have to use that unit at runtime. So that's really important, that the unit that defines that device needs to be used by your application at runtime so that you're able to define that device you're going to use. Now in the IDE, you're going to add a matching entry in that XML file, that mobiledevices.xml file that describes that device. Now I'll give you a link at the end that shows an example of how to build one of these. It's pretty straightforward, pretty easy to do. And you can build one of these or use the ones I've already built for the Moto 360 and the Galaxy Gear Live Android Wear watches. All right, now take a look at the TMultiView component. This is a fabulous component, very useful. The TMultiView component is a sort of a super panel. It's 4 different presentations in one. And actually it could be more than 4 technically, which I'll tell you a little about how the custom presentations work later. But the presentation between the 3 default ones depends on the device kind and orientation. So it automatically adapts to different form factors and orientations and platforms. So for example, in an iPad or a tablet landscape mode, you'll see the layout there at the bottom where it has the controls at the right or the left, but then when you go to portrait mode, it hides that and makes it into a popover, so you can just tap a button and have it pop over. So the different parts of the TMultiView is the TMultiView itself is, in this example here, contains a list box where you see it has the little Acorn, Android, Apple, etc. That list box is on the TMultiView. Okay, and then the TMultiView has a property for a master button and a target control. So the master button is the button that the user taps when the multi-view is not visible to make the multi-view appear. So that button can actually disappear at different times depending on when it should be visible and when it should not be. You don't want to put the button on the multi-view because if the multi-view is not visible, then you can't tap the button to make the multi-view appear. You also have the target control. The target control is what the multi-view is going to appear over typically. So you're usually going to use like a T layout or maybe a T tab control, and it's going to contain other controls. Those are the main that's the main content area. The TMultiView is going to contain the stuff that's only occasionally visible. So it's either going to be, in the case of a tablet or a Windows application, OS 10 application, it's always there, but in other instances, it will be hidden until the button is tapped or the side is swiped, etc. So this is the different modes that you get by default. The platform default is going to automatically adapt the view for you. So this is the default one you're going to get. You say platform default and it automatically adapts based on the platform and the orientation, etc. for you. So you don't have to worry about it at all. But if you want to select a specific view, you can certainly do that as well by changing the mode to popover. So popover is when the user taps the button, the master button, then it appears like you see there. And that's on iOS. On Android, it'll look a little different. So it's still going to behave the same and popping over, but the appearance will be slightly different because it's going to match the Android OS appearance. The drawer, which in my opinion is the coolest user interface paradigm ever, is where it comes in from the left-hand side. So it comes over the top from the left-hand side. You also notice there's an example that has a shadow there. That shadow is optional. You can change that as a property for that. And in this case, the button gets covered when it's opened. So you can tap the button and it'll slide, the drawer will slide out, or you can actually slide from the left, swipe from the left, and the drawer will slide out. And you can actually do it on either the left or the right, which is pretty cool. And then the panel is the docked panel. This is where it's always going to be visible and the button is always hidden because there's no reason to have a button because you don't need to tap to make it appear. So the panel is the one you're going to use when you always have enough real estate. So this is the default you're going to see on iPad or a tablet in landscape mode or on OS 10 or Windows desktop applications. You also have a custom option. Now at the custom option, what you do is you implement TMultiView presentation class. So you descend from the TMultiView presentation class and implement it. There is a default one that you can see in the sample application that's available that just is an alert that pops up in the middle, but you can implement it to have it behave however you want to. You can have it push the master control to the right. You can have it do whatever you want to do. There's all sorts of possibilities there and how you have that behave. Some other behavior things you can do at runtime, though, is you can call hide master or show master to make the drawer open or close, as it were. You can also check to see the state of it. So you want to call has presenter, and has presenter is going to tell you if you have a presenter. Now the presenter is what is doing the presentation of the multi-view. It's the class that handles that. So you should, most of the time, you're going to have a presenter, but you want to call that anyway to make sure you have that assigned. And then you can call presenter.state, and that contains a set of installed, opened, or moving. And so those are the different states the control can be in. The presenter is installed, the presenter is opened, so it's got the drawer opened, or it's moving, either opened or closed. So first thing, let's look at how we're going to create a custom view for FireUI. So what I have is a simple app here, and I'll show you the code here for the Pascal version. What we do, we get the design time width, which is just the form width and height, and display that, and that's going to be the logical size. And then we call our platform services to get the device metric service to get the physical size. This is actual physical pixels on the screen, and the PPI. And then we're also going to call the device service to find out what class this device is. And so this is what the information that we need in order to create our own custom view. So here it is running on my Gear Live. So we see the physical dimensions are 320 by 320. So this is what is returned from the platform metrics here, or display metrics. And then the design, is what we get here, is the actual physical or the logical width and height that is used at design time. You see is 312 or 213 by 213, and the PPI is 240. So there's actually a formula you can use to calculate this all out as well. But the class is tablet. The reason the class is tablet is because when XE7 was released, there were no Android Wear devices released yet. So there wasn't a way to test to see what the class should be, and so it just defaults to tablet, because if it's not a phone, it must be a tablet. So I suspect in a future update we'll see classes besides tablet and phone getting support as those devices show up. So right now it shows up as tablet. Okay, So one note about Android Wear is if you want to launch your app manually, you can just tap the screen and swipe up on here and come down to Start. And then you go to this menu here and you find your app you want to launch. For example, here it is, Hello FireUI, the one I just launched. And you tap it and it launches it. So that's how you can launch your app again if you've already installed it on your Android Wear device. So now once I have that information, then I'm going to create this right here, this class that defines this. Okay. So the view name is the name of the view we're going to use. We're going to call it Gear Live. And we create in the initialization section, we call add device. And here's their class, which is tablet, and our view name. And we specify the size is 320 by 320. So this is the physical size. And here's the logical size. And the platform is Android. And then here is the PPI, pixels per inch, and exclusive. So exclusive means that we don't want this view that we're creating to be used for another device. So let's say we only define a Gear Live view on our application, and then we run that application on a phone, an Android phone. If we don't specify true, then it's going to say, hey, I have a phone, this view defined for this watch, and you know, it's a little smaller than a phone, but I'll go ahead and adapt it anyway, and I'll go ahead and adapt it. You don't want that to happen. So you want for specialized devices like phone, like watches, Android Wear devices, or maybe a TV app or TV display apps, or I'm sorry, TV display devices like the Fire TV, etc., or Google Glass. You want to set exclusive to true, and that means that you're only going to use that view on that specific device. So this is where you define the view, and then in finalization we would remove it. And so this way it gets removed when the app gets removed, the unit gets removed from memory. So here's the XML that we're going to add to our XML document. And so I just put that in here so that you can find it easily. And so this is the file we want to modify. It's in our username, app roaming, Embarcadero, BDS 15 mobile devices XML. So we just come in here and we define the name. It needs to match the name that we had there. 3 is for Android, form factor is for tablet, and then those are just the ordinal values of those enumerations, so you can look them up that way. And so we're only going to enable portrait mode because there's no rotation on a watch. Android Wear only has one orientation. And so this is the location, or the width and height of the display we're going to make there. So this needs to match what we had before in our Pascal files. So this is the logical size, the design size here, okay? And then this is where that is displayed on the artwork, okay? So the artwork, we're going to start at 227 pixels from the top and 313 from the left. Node status bar, and then our artwork is a PNG file. So what I did is I went to Samsung and got one of their images for their watches and downloaded that for that. And then I resized it so that the size of the watch face fits 213 by 213. Okay? And then I just found the upper left corner of it and put that here. So once you've done that, you've defined your mobile device's XML file. And then, which we already saw because I already had this installed, if you come to Designer, we have it available here. So I can select Gear Live. So now I'll explain some of the things I've done later when I'm in the other app talking about the way FireUI works in general as far as the MultiDevice Designer. But you'll notice that when I go to the Moto 360, the circles are visible. And so the circles actually I added, and if we go back to the master view, you can see both of them. There's actually a blue and a red circle here, but they look purple because they're right together. The blue circle is slightly bigger than the red circle. And so what I'm doing here is the red circle is right on the line of what's visible. Now there's actually a little part at the bottom here that's cut off on the Moto 360 for the light sensors right there. So this just is so I can see what would be visible. And so this is actually design surface here. I could put a component there, have something go off the edge, but it wouldn't be visible. So I have the red line just so I can see where that's going to go at, just for the purposes of designing on a round face, watch face. You don't want to have this visible on your watch at runtime. So anyway, there we go. I've defined both the Gear Live and the Moto 360. Now, one trick I discovered is in order for, well, so this isn't a trick, but in order for your app that you designed for one of these new views to work with that view, you have to include the unit that defines the view. So this unit here defines the Gear Live view. This unit here defines the Moto 360 view. So that unit has to be included in your app that's deployed to the watch later. So later when you're making an app that's going to run on the watch, so for example here, this Hello FireUI includes those two files. Okay, so it has to include those in order for it to be able to select those views at runtime. So if it doesn't have the definition of this device, then it can't know to select that view. So hopefully that makes sense. So a trick I found is that if you create a component, so here I've created a component just called Android Wear Views, and this component, all it does is uses these two units. Okay, and then I have a property that just publishes, it says, hey, I support the Gear Live and the Moto 360. Probably a more elegant way to do that, but the main thing is all this component does is uses these two views. And so now I've installed that component because this package has to be installed in order for these views to show up in my list here. So for these views to show up in the list, two things are required. This package that defines the views has to be installed, and you have to add them to your mobile devices XML and then restart your IDE. Once you've done those two things, they'll show up in the list here. But then, since you're installing that package anyway, why not install this component? And then all you have to do is add that component to a app, and your app has access to those views. Okay, so if you don't have those, if you run your app and you say, hey, I want to design it for the Moto 360, and you run it and it uses the master view, you forgot to include the Gear Live device Pascal file in your app. Okay, so you have to include that, and the easy way to do that is to use a component. If you're interested in these are both available in my blog post at the end, and they're all on GitHub, so you can download them. And hopefully I'll be adding other FireUI device views to this in the future. So I have a pretty much new multi-device app. You'll notice right away under new, we just have VCL or multi-device. So there's no FireMonkey desktop versus FireMonkey mobile. You come in here, this is the wizard you can use to select. And so this applies to a multi-device app that will run both desktop and mobile. So this bar here is the new MultiDevice Designer view bar, and so we can change what style we're on. We're on the master view. We can change what style this is. So we say what it would look like on OS 10 versus iOS versus Android. So right off the bat, notice that the toolbar or the tab bar position or the tab control position changes when I go to iOS, and that's because the tab control, tab location, tab control, tab position is set to platform default. So platform default means it adapts to whatever platform we've selected. Okay, so that's the most common scenario you're going to run into the behavior services. You can also use it via code like I showed you in the slides. So now let's look at the way the multi-device designer works. So if I come in here to the views, this gives me a list of all the potential views. Now these two are the custom views I added. The rest of these are stock views that come with XE7. So if we want to design this, basically what you're going to do is you're going to design your UI just like you did in XE6. You're going to set your alignment, set your anchors, your padding, and your margins, etc., to get it laid out the way you want to. But then on some platforms, you're going to want to tweak it. So let's go ahead and say, let's design it for Android 4-inch phone. So we're going to say on Android 4-inch phone, we'll make this button bigger, for example, and we'll change the text on the button to say Android 4-inch. Okay, so now if I go back to the master view, it still has button 1. Those changes didn't take effect, and that's because these changes are only applied to that specific view. So if I add a Android 7-inch tablet, and we'll go ahead and rotate this, we'll notice that, again, this doesn't have that change assigned to it. Now if I go to the code, we'll see here that if I that it has the different devices here. So we have the two Android devices, the tablet and the phone. And if I say view as text, this is just going to show me the text for that particular view. Okay, so if I go back to view as form, and we'll go to the master, which we are on the master now, and say view as text, we'll see now this has all of the controls on it. And that's because we use form inheritance or stream inheritance to only store what's different between the different views. Okay, so let's say on my 7-inch tablet, I'm like, hey, I got a lot more real estate here. I want to add an additional button here. So we'll go ahead and add another button. Let's put it on here. So one thing is this button got added to the master. So all components exist on the master. All right. So since it's on the master, that means it's also on our 4-inch phone. But we don't want a button on our 4-inch phone because we don't have enough screen real estate. So we come over here and we set the visibility to false. Okay. We can't delete it from here. Actually, we can turn it back visible. If I try and delete this, it says introduced an ancestor. That's because it's on the master view. So we can't delete it. We just set it to false, the visibility to false here. So it's still on our tablet, still on our master, but it's not on our 4-inch phone. Okay. If we want to make it visible again, we just simply select it from the list here, button 2, and set the visibility to true. So the thing about these views is you're going to probably do most of your designing at your master view and then only create these device specific views when you want to tweak your view specifically for that. So since I've just created a Android 4-inch phone view, that view will automatically get used for the 3.5 and the 5-inch phone. It'll just use the regular stretching anchors and alignments like we saw previously to make it fit on those as well. Okay, so you don't have to define it for every one of these, but you can. And that's the really cool thing, is you do all the work on your master form, and then you can tweak it on all these other views if you need to, but only if you need to. You don't have to. Okay, so this is really the maximum of reuse and the maximum flexibility all in one. The one thing here is the events. So if I set an event handler here on this one, and we'll say show message button 1, and then we'll go to our 4-inch phone. We saw that same event handler, but we can change it. This is actually kind of cool, is I can come in here to the object inspector events, and I can delete that on-click event handler and make a new one here. Oops, I guess I want to give it a name. Call it Android click, and say show message Android 4-inch. Okay, so now when we're on Android 4-inch, it's going to have a different behavior than it would on any other devices. So we go to Android 7, the button 1 has still the original button 1 click. Okay. Other thing is that we can have this revert back. So here we'll change the text to say Android 7-inch. All right, and I can right click on this and say revert to inherited, and it's going to revert back to inherited. Or I can just change, if I just change the text, let's do the text here again, text change, and then I can right click here. Let's see, I want to right click here and say revert to inherited, and that will change just that one property back. So you can change an entire control or just a property back. So that's the main things you need to know about the way the MultiDevice Designer works. Very cool, very slick, great way to customize your view and take maximum advantage of your effort across as many devices as possible. This is going to really become a big deal, especially on tablets. So the tablet view versus the phone view versus the watch view versus the desktop view. And then let's take a look at the MultiDevice Designer. So the MultiDevice Designer, I'm going to go ahead and run this here, is just an incredibly useful control. So right now we have our MultiDevice Designer, and this, like I said, this is the MultiDevice Designer here, or the TMultiView component here. This is the master area here, master control, which is what this would appear over it. So if we change, right now it's on platform default. On Windows, it just assumes we can display this all the time, so it's the docked view. But we can go, or docked panel. But we can change it to drawer, which is my favorite view. And if I tap this, then the drawer comes out. Displays a nice little shadow over that. We tap back here and it goes away. On a mobile device, I can actually swipe from the left and it will bring the drawer out. Very cool UI paradigm. We can change the drawer position to the right. So now I tap this, it comes in from the right. And again, on a mobile device, if I swipe from the right, now it would come in from the right because that's where it's at. So you can change that way. You can. The shadow is also customizable as well. So right now it says the shadow turned on. We can turn the shadow off. Boop. And now I bring the drawer in. There's no shadow there. Okay. So the other option is we can have it do popover. So popover is where it comes down like a pop-up menu. This is going to look different. So obviously here on Windows, it's overlapping off the edge. On Android, it is completely inside here. And on iOS, it has a little arrow pointing out of it. So there's going to be differences on different platforms. Then there's the split view. Let's change this to, or I'm sorry, the split view. That's the dock panel, where the dock panel's at. And then so popover and drawer are the two platform specific ones. And then you can also do custom. And so custom, you actually define that class that defines how the custom behavior works. And we just tap this. In this case, it's the alert custom, which is going to pop up in the middle. And we can turn the shadow back on again. And there it is with the shadow. Okay, so platform behavior is the default, and that's going to be the default behavior that's most common to that platform. But you can customize this, always have it use a specific type of mode, or customize the behaviors of that, whether it be left, right, overlap. So you can do overlap and pushing, which, so we'll go back to drawer. So now it's going to push. So you see that? It pushed this over instead of overlapped it. So very cool, very flexible, very customizable. Great way to maximize your UI across multiple platforms. So that was a short demonstration of FireUI. And here is a summary for you. Again, FireUI is made up of 3 parts. We have the behavior services. The idea every platform is different, and it allows the platform to allows your application to automatically adapt to these different platforms without you having to write a lot of code to do that. The MultiDevice Designer allows you to have one form that can be different for each platform. So the cool thing is in here, you can still use anchors and alignments and not need to customize it for specific platforms. But if you want to, on certain platforms, you have that option. So this gives you the best of both ends of the spectrum. You can have full customization for each platform, or you can have full reuse for each platform, all combined together with the MultiDevice Designer. And the TMultiView component gives your app that really nice adaptive layout where it can have the common UI paradigms we see on mobile apps, and then also have the UI adapt to different screen sizes, different orientations, as well as desktop and mobile. For more information, check out these links here. The most important one is probably going to be that down at the bottom, the slides and more, which is a link to a blog post that's going to give you a link to download the slides, and also I'll have the replay of this video available there later. And it's going to link to some additional resources besides the ones you see here, like, for example, the Moto 360 and Galaxy Gear Live views that you can install, as well as possibly in the future more views will be available there as well. So check out that link for more information. And now if you joined us for the live session, we'll do some live Q&A. Can you have more than one TMultiView component? So since this is my session, I will be interviewing myself here for this part. And the answer is yes, you can have more than one MultiView component on your application. I actually did one because I was curious about that, if you could have a drawer on the left and a drawer on the right. So I have 2 MultiView components, both pointing to the same master control, and set it both to drawer. And sure enough, swipe in from the left, swipe in from the right, and the drawer opens and closes. obviously, well, I didn't try that, but it would seem like you probably would not want to set both drawers on the left of the same master. That would be probably problematic, although maybe you could disable one or maybe assign different buttons. So one button could open the drawer on the left, the other button could open the second drawer on the left. Both possibilities. Question about make a view for all Android devices and one for all iOS devices. So if you just define one Android phone and one iPhone view, then those views will be used on all Android phones or all iPhones. So the way it works is if you just define your master view, that view will be used on all devices. It just uses the stretching, the alignments and anchors, and etc. If you define then one Android view, so let's say you define the Android 4-inch phone view or 5-inch phone view, then that one will be used on all Android devices, stretched and aligned. So it's going to go through and find whatever view best fits the platform it's on. Okay, and so if you just define an Android view, then the master view will be used for iPhones, and the Android view will be used for all Android devices. But then if you define an Android iPhone view, or if you define an iPhone view, then that view will be used for all iPhones and iPads. But if you want an iPad view, that view will be used override for iPads, and then the iPhone view will be used for all iPhones. Okay. Question about what programming languages can you use. This works with both Object Pascal and C++. There was in the C++ track going on right now, there was a similar session showing the same code samples with C++ as well. Does the multi-view work with 3D elements? Pat, that's a good question. I would think if you were to add a 3D layout to the on the master view, you should be able to do that. Yeah, I would think it should be able to work. I could see that you could do some things that wouldn't work, or you could do some things that might make it a poor UI paradigm. But I don't see any reason why you shouldn't be able to combine some 3D elements in there. I have not tried that though, but based on my other experience with combining some 3D elements with 2D elements, I would suspect you should be able to do that. So the view master is the same for all styles. Yes. So if you, my page is not up yet. So that link, delphi.org/?p equals 1800. That link's not up yet. I apologize. I will get that fixed here in the next few minutes during the next session. I apologize. I forgot to hit publish on that page. I meant to do that and forgot. So the question is, is the view master the same for all styles? Yes. So the master view is the master view for all platforms, all styles. And then you can apply a cross-platform style to that master view. For example, let's say you want to use like transparent, which is one of my favorite ones, not platform specific. You can apply that to the master and it'll be used everywhere. Or you can use Stylebook and apply style specific to the different platforms. So for example, if you wanted to have Android use Android Dark, you could create an Android view, add Stylebook, and use Android Dark on there. You can actually use the same Stylebook across all the platforms. So at the master, you could load a cross-platform style, and then in the Android and iOS views, you could then load views specific to those platforms. So yes, you can use styles across it. You can use the same styles or different styles, just depending on how you want to load it up. What would be the outcome that we learned through this session? So this session covers a number of things, showed you how to use the MultiDevice Designer to design, tweak your user interface for different platforms. So you can define your master view and then define how that master view is different for different platforms, how to create your own custom views, how to use the TMultiView component to create adaptive user interfaces, and how to take advantage of platform services both at design time and runtime to change the operation of your application based on the platform and orientation of the device it's on. Is it easy to change an existing iPhone app XE6 to a multi-view app? Yes, it is. So if you load an existing XE6 app into XE7, it will turn your existing iPhone app or your existing view that you defined in your application to the master view. Okay, so it becomes the master view, and then you can then say, okay, now what would this? Let's create a different view for the iOS versus Android, and you can do that, and it works great. I had a lot of XE6 apps that I brought forward in XE7, and that's exactly what happened. It started out as the master view, and then you can just define your existing views. Does the TMultiView component work with FireMonkey styles, custom styles? It works. Yes, it works with styles. As far as a custom style, it's conceivable that someone has a custom style it doesn't work with, but all of the styles that we ship should work with it just fine. So I guess your mileage may vary, but it should work with most styles that are out there. At least the ones that we provide. Your own custom styles depends on how those are implemented, I suppose. Where will we find the latest views, i.e. iPhone 6 Plus? So that will be in update 1 that you'll find the new styles for iPhone 6 Plus, or you can create your own styles for iPhone 6 Plus. I don't have an iPhone 6 Plus, or I would have made a view for it, but if you follow the details I gave you on creating custom view and you have an iPhone 6, you can totally create one on your own, or if you're able to find the information about the logical versus the physical pixels, then you can get it to work. Okay, David's saying none of the links work, so I will check that out. They should all work fine, but could be something changed behind the scenes and it's not working. So I will work on fixing those links. If you go to the delphi.org/question P1800 or just delphi.org in the next 15 minutes, then I'll have all those links up there for sure. Okay?